Hello everyone, welcome back again to Ascend the Pathway of Education. Myself Abhijyotishan, representing another new video on the topic Human Eye and the Colorful World, the chapter number 11 of your NCERT book. It is, as I told in the previous video, that this video is going to be one of the most interesting chapter of physics. And also some biological part is related, as it is related to our body, human body, that is human eye. So let's see, today's chapter is the human eye and the colorful world. Human eye and the colorful world. So it is going to be our sixth chapter of our syllabus. Okay, we have till now completed the 5 chapters, and this is our 6 chapters, that is 2 chapters from chemistry, 2 chapters from biology, and 1 from physics. So this is the second chapter from the physics portion. Okay, and what is the situation now? And it's hot, it's very hot, but actually I want to give a social message to everyone. Yeah, I know it's impossible for everyone mostly to put off the AC and leave now in this condition, in this weather, but I will request, if instead of 24 hours, I know 24 hours is not possible, instead of 20 hours only, if we put off our AC for just 2 hours, that is 18 hours is okay, we can. 2 hours we have to add, we have to just what to say we have to just adjust 2 hours. Okay, so that will increase actually that will decrease the level of the temperature of our weather. Okay, as much as we will continue turning on the AC, the weather temperature is turning high. Okay, so it's our duty, as we know what is sustainable development. Just you all imagine, if these type of AC's conditions continues, what will be the scenario of our environment after 15 to 20 years? Just suppose after 10 years, not 15 to 20 years, that's a very long span. Okay, after 10 years, what will be the scenario? Okay, I think that will reach up to the 50 degrees Celsius. So it's our duty to minimize the usage of our air conditioners and decrease the temperatures naturally of our environment, but not by the turning on our AC, that is air conditioner, only just inside our room. Okay, because it's not possible for everyone to stay in the room each and every time. Okay, the person will go outside in work, so some children will play. So it's our duty also how to decrease the temperatures in nature, not only in our room but also in nature. So please, it's my request to you all, please minimize the usage of air conditioner as much as possible. Okay, so this much we can say, this much we can do. I think this much we can at least try for ourselves, for our future generations. Okay, so let's do this chapter, human eye. What is the use of human eye? What is the use? We actually capture the light, the things around us are getting reflected by the light, and that is entering our eye through the retina, through the pupil. It is crossing the lens, and that light is forming image on the retina. What is retina? A retina is a screen-like structure, a screen muscular-like structure present inside in the inner side of our eye. Okay. Okay, so the first, what are the components of our human eye? Let us see first that. Pupil, lens, we all know there is a lens. Okay. Optic nerve, nerves, then retina, 5, ciliary muscles, 6, one is aqueous humor, the 7th one is iris, and cornea. Okay, so these are the 8 components by which a human eye is made up of. Okay, each and every normal eye consists of each one of this. Each one of this will be present inside a normal healthy human eye in the perfect condition. Okay, not like that retina is somewhere defected. That is not that will not be called as a healthy human eye. That will be defected human eye. Okay, so and also there are many problems in the lens. Okay, due to the usage of phone, laptop, we know that power increase and decreases. What is that? How to perfect that? How the doctors deal with that kind of problems of our human eye? We will see those things in this chapter. Okay. Okay. So now we will see the functions and the definitions of each of those. Okay. So the first one which we will see is pupil. Function of pupil. Okay. It is the black hole in the center of the iris of the eye. Okay, which permits light to enter. Okay, what is pupil? It is the black hole in the center of the iris which allows the light to enter our eye. Okay, so through that black hole the light actually enters our human eye and forms the image in the retina of our human. Okay, please note it down. The second one is iris. What is the function? It is a dark muscular diaphragm. Dark muscular diaphragm which controls the size of the pupil. Okay, that is the black portion of our human eye. Right? Okay, it is not black for everyone. For someone it is brown, dark brown, light brown, green. Okay, cat's eye. Okay, so there are so many colors that differs from heritage. Okay, and this will also we will see in the chapter number actually I forgot, that is most probably the next chapter of the human reproduction in the biology portion of our class 10. There we will see what is heredity. Heredity and evolution. Okay, that will be the chapter of biology we will read exactly after the human reproduction. Okay, from there we will see that how the trait is inherited from our parents, how we, okay, so those are the things which we will see, but now we are doing this thing, don't get excited. Okay, so please note it down. It is the dark muscular diaphragm which controls the size of the pupil. Okay, if we stretch our eye, that is the iris is stretching our eye, and the dark hole of that is the pupil is getting larger, so that the light is getting inside, more light. Okay, we are stretching and we are doing this. Okay, light is coming, we are squeezing our eye, that is the black hole is getting reduced in size. Okay, the third one, lens. What is the function of lens? It is a transparent structure present behind the iris. Okay, that is the colored part of the eye. That is, it is very small in size. If we see very clearly, then only we can see. Okay, then we can notice it. It bends the light rays. In the previous chapter of physics we have seen. Okay, function of lens, it is getting reflected, in lens it is not getting reflected, mostly it is done by refraction. Okay, light rays, so that they form a clear image in the retina. Okay, it is a transparent structure present behind the iris. It bends the light rays so that they form a clear image in the retina. If lens is not so clear, then the image will also not form very clear in the retina, and we can't see those images very clearly. Now the fourth, that is ciliary muscles. Ciliary muscles. The ciliary body, it is a circular structure. It is a circular structure and it lies between the iris and choroid. Okay. It changes the shape of the lens. Changes the shape of the lens when your eye focus on a near object. The best example of this statement, that is the ciliary muscles, is first we will notice our this finger in this position and here. Okay, suddenly the finger is not getting hazed. Okay, we quickly just shifted our eye into this finger and it is clear to us. But if we place this finger in here, can we say it? Okay, that is called the near point, that is 25 centimeter. If we place any object less than 25 centimeter from our eye, that is below the 25 centimeter, that is the near point. Okay, so it is violating the law. Okay, our eye will not be able to see those objects near than that is lower than 25 centimeter, that is near point of our eye. Okay, note it down. It is a circular structure and it lies between the iris and choroid. It changes the shape of the lens and focus on a near object. Fifth one, optic nerve. Optic nerve. Acha, what is the definition or the function of optic nerve? Which is present outside the eyeball, that is in beside the retina of our eye. Okay, actually it transmits electrical impulses, that is whatever the image is formed in our retina, that will be not be enough to understand what is that. That message should be sent to our brain, that okay, I am seeing such a type object, okay, what is that? The message will be sent through the optic nerve, that is it transmits the electrical impulses to our brain, and our brain will identify, okay, she is that, he is that, okay, this object is okay. So the main function of this optic nerve is to transmit the electrical impulses, whatever we see, to transmit that image from our eye to the our brain. Okay, please note it down. It transmits electrical impulses to our brain. Sixth one. Okay, now the retina. Till now we have heard many a times what is retina. Retina is doing this. Okay, till now we have understood that the basic portion of this retina, that it is actually the screen where the image is formed after reflected by the light. Okay, it captures the light that enters our eye and helps translate into image we see. As I told that only forming an image will not be enough to understand. Also it enters our eye and helps to translate the light into the image what we are seeing. Okay, note it down. It captures the light that enters our eye and helps to translate into the image we see. Now the seventh one, cornea. Its main function is to refract the light entering our eye. I don't think that there is anything to make you guys understand in this statement. It is very simple. Is to refract the light entering our eye. Its work is to refract the light rays entering our eye. It's very simple. Its work is to refract the light rays entering our eye. And now the aqueous humor. The last one, aqueous humor. It maintains the pressure needed to inflate the eye. Aqueous humor is the liquid portion of our eye. When we touch our eye, we feel like something liquid is present, some liquid. Okay, so that is the aqueous humor. It helps, it prevents our eye to get dried up. Okay, and we know how it feels that if our eye gets dried up. So aqueous humor is doing that only, preventing our eye from getting dried up. And provides nutrition for the central cornea. Okay. Aqueous humor, it maintains the pressure needed to inflate the eye and provide nutrition for the central cornea. Okay, so this much up to the human eye, that is the human eye portion, the functions and the definitions of each and every portions of the human eye. Okay. Okay. Now we will see power of accommodation. Power of accommodation. What is power of accommodation? As we know, ciliary muscles helps our eye to get stretched. Okay, so the amount of stretch or the amount of changes we can bring to our human eye is known as power of accommodation. This can't be we can't stretch our eye up to this or this. Okay, that is only possible in cartoon. Okay, so the amount by which we can bring the change in our human eye is known as power of accommodation. Our eye is composed of fibrous jelly-like materials. Okay. Through the ciliary muscles the eye can be stretched at some extent. Okay, there is a fixed point. There is a limitation up to which we can extend our eye. So the amount of change can bring to our eye is known as power of accommodation. Note it down. Our eye is composed of fibrous jelly-like materials. Through these ciliary muscles, the eye can stretch at some extent, okay, up to some extent. So the amount of change we can bring to our eye is known as power of accommodation. Okay. So the next portion which we will see is the defects of vision. As we have seen that the topic of human eye by which doctor deals with. Okay. So okay, wait a minute. Continue. So the defects of our human eye, there can be many. There is sometimes we can't see the far away objects, sometimes we can't see nearby objects. Okay, sometimes there are both happening once in a time. That is known as presbyopia. We will see that mainly happens with the old aged person. When the two occurs at a time, that mainly occurs in the old aged person. Okay. The first one is myopia. Myopia. What is known as myopia, or what is the defects, or what are the changes taking place in our human eye so that we are facing problem? Myopia is also known as nearsightedness. Nearsightedness. What is happening to that? Can see only nearby objects clearly. The person having myopia can only see nearby objects, can't see far away objects. Okay. So we have to learn by this manner. Okay, the first thing which we have to keep it in our mind, that is we don't have to get mixed up with the nearsightedness, farsightedness, that is myopia, and the hypermetropia. Okay, step by step we will learn. Myopia, known as nearsightedness. What is nearsightedness? As the name only, we can understand that nearsightedness, the person can only see near objects, not far away placed objects. Okay, that is the person having problem in seeing far away objects. Why it is happening? Why it is happening? So there are two problems for that it is happening, that is excessive curvature of eye lens. Excessive curvature of eye lens, and the second point is elongation of the eyeball. Okay, what is actually happening now we will see in the structure. The normal human eye is the lens, the bulged portion. Okay, a lens is present here. It is a lens. Ray is coming. Ray is coming. Getting refracted through the eye lens and forming an image to the retina. This portion is the retina where the image is formed. So it is a normal human eye. It is a normal human eye. But in the case of nearsightedness, what is happening? Let's rub this out. In this problem, nearsightedness, rays are coming parallel. Okay, I think it is clear. Otherwise, I will make it larger. So what is happening here? The image or the light rays is not able to reach the retina. That it is image is forming before the retina. It is not forming the image in the retina. As a result, through the optic nerves, as image is not forming in the retina, the impulses will also be not able to be sent through the optic nerves. Okay, and as usual, step by step, our brain will also not receive the electrical impulses. We will also not able to see what is happening there. It will be what to say, light, means that is, it will be faded. So it is actually this portion. How to correct it? How to correct it? For that portion, concave lens is used to correct or rectify the problems. Arrow is must. Okay, so we will use concave lens in the case of myopia. Concave lens. Concave lens we will use, that is like this way. Human eye lens. Here we will place, that is the specs. It is just present before our human eye. Concave lens. It is before reaching our eye, it have to be passed from concave lens. What will concave lens do? We have see already. Okay. We have to see. We have to place this little closure. Okay. That's little bigger. What is happening? Light rays are passing through concave lens. It will diverge the rays. It will diverge the rays. That is, light rays passing through the concave lens. It is diverged. It is diverged. Then it will form in this way. I hope it is clear. The main thing is happening. It is concave lens. First note it down. Can only see nearby objects, can't see far away objects. why it is happening, the reasons: excessive curvature of the eye lens, excessive curvature, that is elongation of the eyeball. As the light rays are going normally, but the eyeball is elongated, so that's why it is not able to reach up to the elongated part of the eyeball. Okay, written. We have seen what is happening there. We will not draw this one, but we will see. Let us rub this also. I hope you all understood that what is happening in this case in the diagram. Okay, eye lens, concave lens placed, light rays are falling, getting refracted, it is diverged, that is like this. It is not going straight, it get diverged, and it will now form the image on the retina. See, it is diverged, so the area increased, and automatically the refraction will also increase, so the distance became normal. Okay, so there is so many kinds of power, +1, +2, +3, +1.75, +1.5. Okay, that is there are so many machines present to the doctors. They will prescribe you of how, means actually I'm not a doctor, I don't know also that one, but yeah, the main funda is that they will prescribe you the power of the concave lens by which you will able to see. Not like that your eye will be able to see in +2 only, power of +2 concave lens, but the doctor will prescribe you the +3 concave lens. Okay, in that also it will make problem, it will be difficulty to see objects. So myopia is finished. Myopia is finished. Now the hypermetropia. Number 5. Hypermetropia. First let us see the written portion, then I will rub all those things, you will write, and there I will draw the big one diagram. Okay. Okay, hypermetropia is known as farsightedness. Farsightedness, that means can only see far away objects. Far away objects, can't see nearby objects. That is having the problem in seeing the nearby objects. Okay, so why it is happening so? What are the changes? That is the focal length of the eye lens became too short. That is the line which I was drawing. That is the focal length. That focal length is becoming too short. Focal length became too short. The Second one is the eyeball has become too small. That was elongation of the eyeball. The light rays was unable to reach that portion, but it is the eyeball became too short. The eyeball became too short. Write all those things. Can only see far away objects, can't see nearby objects. Nearby objects. Why it is happening so? Focal length has become too short, the eyeball became too short. Okay, let me write what is the lens which we have to use. Convex lens. Convex lens we will use to correct the hypermetropia. I am not again drawing the normal human eye. We all know what is actually what is the main funda of normal human eye, how the image is forming. So I will only draw two diagrams, that is what is the problem of hypermetropia, what is happening where the image is forming, and after correcting it. Okay. Eye, focal length, has become too short. We all know focal length. So the light rays is going like this way, and after getting refracted, it is exceeding the retina. It is exceeding the retina. Okay, is it forming on the retina? No, it is exceeding the retina. So how to rectify it? The main thing which we have to do is bring the focal length into the normal condition, not too short. Okay, convex lens. So the lens, the rays are going in this way, refracted, little refracted. Okay, so it will not form in here. After getting refracted little, it will again form in this way. So the main thing is two refractions are taking place. Light rays after getting the specs, that is human placed convex lens like this way, and again after getting refracted through the human placed the human eye lens, it will again refract in this way. So this is the thing. Okay, human eye, human placed eye, and this one is the which we will place. Okay, so the next one is presbyopia. Presbyopia, but it is nothing. In this case we don't have to draw such diagrams. Okay, presbyopia is only the theory portion is there on the NCERT. What is presbyopia? Person having both means myopia and hypermetropia. Please note it down. Person having both the problems, myopia and the hypermetropia, that is neither can see the faraway objects nor can see the nearby objects. As I told that it is mainly happening, it is caused to the old aged persons. Okay, so how to correct it? We have to use both the lens, that is there is also a special lens, bifocal lens. The type of lens which contains both the bifocal lens. Okay, so in the upper portion of our eye, that is the specs, it will be can see farsightedness. So in the upper portion it will contain that concave lens. And in the lower portion of this, in our grandparents' specs, we have seen that they were a special type of specs, that it is plain and here a half circle, hemisphere type something can be noticeable. So the lower portion, that half moon like thing, is that the convex lens. Okay, so when we read something that is nearby objects, we see through the down portion. It is the human psychology. Okay, our eye automatically goes in downwards like this way and we read something, so convex lens, and the upper portion to see the faraway objects, that is the concave lens. So here we go with the presbyopia. Okay. Okay. Now we will see refraction of light through prism. Okay, a simple triangle and it is too wide, but still it's okay. So first we will see that what are the rays or the definitions. Okay, for a diagram of science department, the perfect diagram, okay, a perfect diagram is needed, but the thing which is most required is the leveling. Okay, okay, so this is the normal, this is the continuation of this ray, this is the refracted ray. Okay, first let me give me the arrows. Same here, it is also changing its medium, that is from the prism to the air, that is air to the prism, again prism to the air. Okay, so here we will also draw a normal, continuation. Okay, so the angle which is formed over here, the angle formed by the continuation of the two rays. Okay, this is known as angle of deviation. This one. Okay, angle of deviation. I will request everyone to please draw this diagram and mark all those things, because this is one of the most required diagrams of this chapter especially. Okay, angle of deviation. Okay, so P Q R S, then the two angles I. What is this angle known as? Okay, what is this angle known as? First, this is angle of incidence. Okay, here angle of incidence. This is angle of incidence, that is this one. This is known as angle of refraction. Angle of refraction. Okay, and this one is the angle which is formed by, okay, first this diagram, n dash, m dash, two normals are there, n dash, m dash. The angle formed by the m dash normal to the refracted ray, that is R, this one. This is known as angle of emergence. Angle of emergence. I think my handwriting is improved. Okay. Then we all know that what are the incident ray, refracted ray. Incident ray, refracted ray, emergent ray. Okay, so okay, one more thing you have to remember, that this one is very simple. The angle at the top, this is known as angle of prism. Angle of prism. Okay, done. So the conclusion of this diagram is, whenever a ray of light passes through the prism, this way the light enters and the light rays deviate in this way, that is incident ray, refracted ray, emergent ray. Lighter medium to the rarer medium, rarer medium to the lighter medium. This is very simple, as we have already discussed what happens in the refraction time. So the same thing happens, it enters from the air medium to the glass medium, and again glass medium to the air medium. Okay, so the next part which we will see is basically the understanding part. Okay, not very mathematical part, but the understanding part, that is what better. In this part you guys have to remember many of the things, such as why we see the sun late. Okay, the reasons which we are going to discuss are atmospheric refraction, scattering of light, etc. Okay, before that, 1 minute, one thing I have to say again about the prism is, this is the prism. Suppose a white light enters, suppose not, a light ray will enter that is white in color, that will be light, white ray or white light, and this will continue in this way. The thing which is, it divides into several components of the white light, that is dispersion of white light, DISPERSION, dispersion of white light. That is, when it enters the glass medium, it divides into its 7 components colors, that is 1, 2, 3, 4, 5, 6, 7. Okay, so it can in this way. So what are the 7 colors? VIBGYOR, the rainbow color, that is VIBGYOR. And how it goes? VIBGYO. Okay, one more. VIBGYOR. Here we can see more clearly. Okay. The lowest one is this one, V, above I. Not like that this VIBGYOR will start from the above to the end, but it will start from the end, that is the lower point, to the up point. VIBGYOR. The high, the most above one is the red color, that is VIBGYOR, red color, that is the most above one. Okay. Okay, now we will see how the rainbows are formed. We all know that after a short rain, we get to see rainbow when again we get to see the sunlight. Okay, that is after think the whole part in a sequence. Okay, rain occurs, rain take place, the water droplets are still present in the atmosphere, they are still there, okay, in the atmosphere. Then sunlight comes, that is the white light. After all, it is the water droplets. That means it will also refract, it will also change its medium. What I said, in the refraction time, white light divides itself into its 7 components colors, that is VIBGYOR will divide its 7 components. Okay, inside this only all are there. Okay, they are hitting the another side of the water droplets. After that, what will happen? It will reflect, not refract, it will reflect. Okay, then again it will come in the refraction medium, that is 1, 2, 3, 4, 5, 6, 7. Okay, so what actually happens? First, water droplet is there, white light strikes it, refraction occurs, it gets divided into its 7 component colors. Then into the another side of the water droplets, those 7 component colors get reflected, not refracted. If that is refracted, then it would go in this way. Okay, not refracted, it will go in the reflection mode. Refraction occurs, and after that reflects again, it's come into the another side. Then it again refraction occurs, it changes its pathway, and the 7 components from a white light, we get those 7 components colors outside the water droplet. Water droplet. This is white light. Okay. Here refraction occurs. Here in this way reflection occurs. Reflection, and here again refraction occurs. So 3 things occurs: refraction, reflection, or again refraction. Okay, so this is the main thing, how from a light, from a white light, that is sun ray, we get this 7 components colors, that is rainbow, after a short ray. Okay. Now we will see why we are unable to see these stars in its right position. That is, suppose a man, a person, let it be a man, okay, standing here, he or she, let it be me, okay, so he, a star is actually present here, so it should come in this way, but instead of this me is getting to see it's in this position. Why? Why this is happening? Star is present here, so I should get it seeing in this way, in this position only. So why I am getting the star seeing in this position? Because after all, star is not present inside the atmosphere of the earth. Star view, that is the light, have to enter from the past the atmosphere. This is earth. I am standing on the earth. I am seeing this from the earth. Earth has its own atmosphere. This is the atmosphere. So the light ray have to pass from its atmosphere, right? This is atmosphere. So it have to pass from the atmosphere, and while changing the medium, that is from the space to the galaxy, it is changing its pathway. This is normal, it is going far away. Okay, so in this way the refraction occurs when the light rays enters the atmosphere of the earth, and it changes its pathway, and in that position we are able to we are getting it to see over here instead of this position. Okay, so instead of this position, why we are able to why we are getting to see it here? Because of the refraction of the atmosphere. In one word we can say that is atmospheric refraction. Okay, so all these parts are the parts of the atmospheric refraction. Okay, formation of rainbow, seeing of these stars, all these are the parts of the atmospheric refraction. This one is was the twinkling of the stars. In your NCERT book, this only there are many subparts under the atmospheric refraction. So this is one of the parts, twinkling of stars. The second subpart is, this is Earth. Okay. This is Earth. This is atmosphere of the Earth. This is the atmosphere of the Earth. Okay, I know this man is too big, can be visible from here, that is from the galaxy, but still, Sun is actually present here. Sun is actually present here, so it should be visible, the same thing. It should be present here, but we are getting it to see here, not in its right position. The same thing, the refraction occurs and we are getting to see the sun in its lower position. Okay, that is, we are not getting to see the sun in its right position. We are getting extracted from that medium. Okay. Okay, so the next part which we are going to do is the scattering of light, that is, why is the color of the clear sky is blue. This part I don't think not. This can't be represented in board. This is the this is the theory one. So I am just telling why it actually happens. There is nothing to write on the board. Okay, why it is happening? So why we are getting to see the clear sky in blue color? Because of the length of the wavelengths of the color. Okay, wavelength is a term of each and every color contains this wavelength, has its own wavelength. So blue has the lightest wavelength of all the colors. Blue is that is sky blue has the lightest wavelength of all the colors, and the amount of wavelength will decide how much it will refracted in the atmosphere. Okay, as red has the highest wavelength, so it is not getting chance to enter or to get refracted into the atmosphere. Okay, as it has the highest wavelength of among all the colors, it is not getting chance to refracted in the atmosphere, and as sky blue has the lightest wavelength, that is the smallest wavelength, it is getting chance. So through the atmosphere it is getting refracted the most, and we are getting to see the clear sky blue in color. And now the question may appear in your mind that in the evening side why it appears orange or red, as because of the conditions of the atmosphere. Okay, we all know that atmosphere does not contain the same condition each and every time. It appears to change each and every time. So as the evening, morning, all this getting changed, the conditions also changes, and according to that the wavelengths are same, wavelengths are not changing, but the situations are changing of our atmosphere. Okay, so according to that, wavelengths will decide how much color it will refract. So as I have told many times, sky blue has the lightest wavelength. So question may appear, why sky why the clear sky is blue in color. So simply you will write because of its smallest wavelength speciality. Okay, because of its smallest wavelength. Blue has the smallest wavelength and red has the highest wavelength. Okay, so this is the last portion of this chapter. Okay, here we go with the end of this chapter. I hope that you all have understand this chapter very nicely. I'm not saying that you have to understand, no. If any problem is still there, please let me know in the comment section. I will surely try my best to clarify those portions again and again to you all. I will make a special part on that. I will make a special video on that special part where you guys have problems. Again, we will meet in the next chapter. That is the third chapter of chemistry, that is metals and non-metals. We have done 6 chapters of our NCERT book, 2 from chemistry, 2 from biology, 2 from physics. So our next chapter will be metals and non-metals, that is third chapter of chemistry. So we will cover that part. Hope we will meet soon. Till that, take care and bye bye. Okay, and if you like my video, please like and subscribe my channel and share my channel and those videos. If you feel comfortable with me, please share these videos with your friend. Okay, bye.